but the negative, once we graph these things on here, you're going to see it comes through the pole. It's just the opposite side. And because we are a directed distance, we never really have a negative. So the point name is there, but the actual point is not. The angles we're going to send through. Now, we're just going to do the angles, God bless you, based on 2 pi or 360. So once we go out of that range, like we're not going to do like we did in trade, add it and keep on going and going, or subtract it and keep on going and going with the 2n pi thing. We're just going to stay from 0 to 2 pi, from negative 2 pi to positive 2 pi. So these are the only ways we're going to go with our angles. Not so bad. Once we start plotting these, you'll kind of see this. So if I have a point, and the point is 2 pi over 3, all I have to do is find my radius of 2, stay in that radius, and find my angle, and you can find it on your graph that says pi over 3. So it's going to lie 2 units away from the pole on the terminal side of where pi over 3 would be. So if this is where my pi over 3 would be, it's going to lie here on this part. It's only going to come out to the 2 like this. Okay. If I have an angle 3, negative pi over 6, I'm going to come out to the 3rd loop, radius of 3. That's my directed distance. My angle is negative, so my angle is going this way. So on my line of my pi over 6, I'm going to come out this far and name this point. So it's not so bad. So it's still like an XY point, but the XY part is a radius and an angle. Okay, the angle can be negative because you can go clockwise, and the radius has to stay positive, except when we name another point for it. You can send this here through the pole and name this point using a negative. And we'll do that in a second, as long as you get used to doing this. Anything at the 0 is right on the, like the origin, if you will, at the pole. Because the 0 is an angle of 0, of a radius of 0, puts you right here. So it doesn't matter what angle you're at, you're going to be at the 0. So let's take a look at some of these. Alright, unfortunately I'm going to have to move this down. What was that point? Two pi over 6. So we're going to find, oh my goodness. We're going to find all your points for 2 pi over 6. How come this keeps expanding on me? Alright. Maybe that's the best I can get. Alright, so when we do this, is that the only point that it has on yours? Is that the only point?
Then we have only like
Oh, you have it on your grid. Okay. Alright, you can, so the grid that I gave you with all the points on it, you can plot it right there. That'll work. Alright, so 2 pi over 6. So let's find your radius of 2. Here's your radius of 1. Here's your radius of 2. So you're in that circle, and you're going to find pi over 6. These make me blind. Totally blind. And my board is always a little bit off, so my points are never exactly on the pole.
You did that because it's 2?
2, a radius of 2. That's your directed distance. Find your, it's very hard to kind of see. So find your 1 and then come out to 2 and plot that point. Yes. Go ahead.
Oh no, I figured it out.
You good? Okay. Now, because we do this and we take this point and we say 2, we take your angle plus or minus 2 pi. We're going to see what other angles this makes because it can come around or go around the other way. So we're just going to take your angle, we're going to convert this again to whatever denominator that is. So this is 12 pi, oops, sorry about that, 6, 12 pi over 6 will give me 2 pi. So take the pi over 6, keep the 2 for now, take the pi over 6 and add 12 pi over 6. Keep the 2 and subtract 12 pi over 6. So you have these two angles. Now we're going to stay between 2 pi and pi. One of these is out of the range. This guy, right? So we're not going to use him. Okay? And that would make sense not to use him because if I add 2 pi, I will be out of my 2 pi circle. Sometimes when you have a negative and you add 2 pi, that will work. But, so just the concept of we're going to stay within 2 pi. Yep. No, we're only doing this so that we go around once. We're only doing the range of 2 pi to negative 2 pi. We're only going around our circle once. Whereas your normal angles can go around like the 2n pi when we add 2n pi or we add n pi where n is any odd integer. We're not doing any of that. We're just going to name them going from 2 pi to negative 2 pi. That is it. Now, to take the negative of this, technically, and I'll show you where that point is, it technically doesn't exist. This point right here, if I went and I started on the circle of 2 and I came around negative and just kind of watch my pen a minute, it's coming around to the negative pi over 6. Wouldn't that hit that point? Wouldn't this point be the exact same? Right? Because this would be 12 pi over 6 over here. So if I came around, starting here at the terminal side, on the 2 radius, and I came all the way around, there would be my negative 11 pi over 6. That point exists. So we came the opposite way. Now, your negative doesn't quite exist. If I negate this, you're going to plus or minus pi. I don't know how to get rid of this thing over here somehow. Oh, there it comes. Because, and I'll show you in a second, we technically have a negative point, but we can't graph it. We can name it, but we can't graph it. It's going to go through the pole. We're not going to plot it. We're just going to name it, and I'll show you in a second where it goes. So again, just take this. Just bear with me for a minute. This is the toughest concept. So we're going to add and subtract 6 pi. So you're going to get negative 2, 7 pi over 6. And you're going to get negative 2, subtract it, negative 5 pi over 6. Now, technically that point is going to come straight through this pole. It's going to be on this, I'm just going to put a dot here, but we're not going to plot it. It's going to come through this thing and technically be right over here somewhere, right? It's going to come right through the pole. If I send this through the pole, did I miss the line? If you come through the pole, it will be right here. So isn't this 7 pi over 6? If I came across and I landed on 7 pi over 6, just follow yours. It's going to be easier to see than looking up here. If I came directly across through the pole, I'd be on the radius of 2. I'd be at 7 pi over 6. If I came the negative way, this way, this is, if I came negative 5 pi over 6, this would be negative 6 pi over 6. So this would be negative 5 pi over 6. And if I came here, if I could plot this point, it would be right there. But we don't plot it. We just name it. Tough concept, but we just name it. Technically, it exists through the pole. We go straight through the pole. It's like being on the opposite side of the world. We go straight through the pole, and we have this 2 negative points. One coming counterclockwise in the positive direction, one coming clockwise in the negative direction. And if we could plot it, it would meet right there, right through the pole. All we do is name it. We don't plot it. Negative 5 pi over 6. Because the negative comes this way. So 7 pi over 6 makes perfect sense because watch. We come straight through here. I'm just going to draw an angle thing here. We come straight through here, 180 away, right? So 180 away says, oh, you should be on this line, 7 pi over 6. You should be at my radius 2. Negative 5 pi over 6 comes the opposite way, this way. And I come 180 that way. So if I was coming this way, this would technically be negative 6 pi over 6. One before it would be negative 5 pi over 6. So technically, I'd plot that point right there if I could. I can't plot it, but I have to name it. So this point has 4 names. This name, this name, this one, and this one. But we've only plot the positive radius. Make sense? All you're doing is adding and subtracting 2 pi, making it negative, adding and subtracting pi. Just don't plot the negative. Just make sure that you're going straight through the pole to get there. Straight through the pole is 180 degrees away. All the way around is 360. That's my 2 pi. So I'm either coming all the way back around, but I have to stay within 2 pi to negative 2 pi. That's the only thing. There's no plus n, there's no plus 2n pi anymore.
So the end would probably have 14 points.
Sometimes. Sometimes you get 4, sometimes you get 3. Depending on your range. 4. You have to count the original. You only plot 1 point. You're only plotting 1 point. 4 names. 4 names to this point. Only should get 1 dot. Does that make sense?
Yeah, I think we're playing for dots.
No. We only get 1 dot. This dot here. Because this is the same place as this one is. This one's through the pole, and that's the same place if I could plot that. But I can't plot it. Okay, we're going to try some more. I gave you a sheet, right? With this on it? Alright, so let's try a couple others. I wonder if I shrink this down, if it would be better. Okay, so let's try this. Once you get used to it, it's not that bad. It's just a difficult concept, like where did we put the negative one? We didn't. It just is a name for your point. Okay, so let's try the first one. And unfortunately, you just have to convert your denominators. Because you're either adding 2 pi, adding and subtracting 2 pi for your angle, or you're taking your radius, or you're taking your negative radius and taking your angle and adding and subtracting pi.
Since we only have like 3 different coordinate things, we just plot like...
That one you can plot all on one. The one that I gave you with the sheet, you can plot that on one. The one for the homework, I gave you 2 different ones. Like, use half of them on one, half of them on the other. You're only plotting 1 point per problem. So, and just label the problem. You want to label it A, B, C, D, E. You want to label it 1, 2, 3, 4, 5, 6. Whatever you want to label it. You're just getting 1 point. So let's find this point. This point is coming out radius of 2. Radius of 2, pi over 3. Somewhere, sorry, my board is always off. So somewhere right there is your point. Okay, radius of 2, pi over 3.
Why do we add 2 pi?
Yes, that's what we want, different names for the same point. This is exactly what we want, a different name for the same point. We're only plotting 1 point, Bob. 1 point, but we can call this point up to 4 different ways, using a negative and a positive. So you're absolutely right. That's why this is a tough concept to get, because we're still only getting 1 point. How many ways can we name this? You remember back in trig when we found angles and we kept saying plus n pi, plus 2n pi, because they can go on endlessly. This is only going from negative 2 pi to positive 2 pi. That's it. So somewhere in there we have different names for it. So all you have to do is this. Take this, plus or minus 2 pi. Now, obviously, if you add 2 pi to this, isn't that going to knock you out of your range because it's already at 3 pi? But we're going to do it anyway. So convert these to same denominator. So every time you add and subtract, you're adding 6. So I'm going to get, this is my original, I'm going to get 7 pi over 3. Just bear with me. And I'm subtracting this, negative 5 pi over 3. Okay, 7 pi over 3 puts us twice around, right? I came back through. So I'm going to take this point out. And you can kind of see that, and don't add the 2 pi, but I'm doing this so that you can see this is the process. Okay. So far we have this one and we have this one. Now, if I come here to negative 5 pi over 3, this is my 3 pi over 3, this is my 6 pi over 3. So when I come negative, there's my 6 pi, I stop one short, there's my negative 5 pi. Aren't I at the same point?
Where do you cross that?
Because I'm over 2 pi technically. If I divide that, I'm over it. That's my range, from negative 2 pi to positive 2 pi. So now, the second part of this is, it's the same point. My graph is off because my points are, my thing is not very calibrated. So it's right here at the radius of 2 on the angle of pi over 3.
You at least plot the original.
Plot the original, well, unless it's negative, you can't plot the negative. Then we're going to have to use the positive of it. And we'll do one that's negative here. I'll do the last one, has a negative. We can't plot that. You can only plot the positive. So radius of 2, you're only going to get 1 point for all of this. So now, you're going to take a negative, we're going to take your angle, and add and subtract pi. It's technically through the pole. We got to see what we should call this. So again, I'm going to convert this denominator. Now I'm going to get negative 2, 4 pi over 3, and I'm going to get negative 2, negative 2 pi over 3. Now, that should come straight through your pole. If you came through your pole, that would be right over here. If I could plot it, it would be right here. Am I at the, whatever that is down there, 4 pi over 3? Am I at the 4 pi over 3? Are you at the 4 pi over 3 if you put your finger through the pole?
Mm-hmm.
Okay, and if I came negative, that means I have to come all the way around from the negative side. Oh, we did a negative 2 pi over 3. This would be 3 pi over 3, so 1 less would be 2 pi over 3. And it has to add up to 6, whatever one you're doing to make 2 pi. So straight through. But I don't plot that point. Can't plot a negative. I get 1 point for all those 4 things. Make sense? Probably not yet, but you'll get the hang of it. I'm still just getting one little dot there. Let's try one more positive one, and then we'll do a negative one. Questions? You okay with this? Okay. All right, let's try number 2. Can I plot that point?
Oh, yeah.
Yeah, it has positive radius. A negative radius I can't. But a positive radius I can plot. So it's coming out 3. Here's my third, and it's coming to negative pi over 6, which would be at what point? 11 pi over 6. So I already can name that point almost, right? I know it's going to be 11 pi over 6, right? So shouldn't one of my points be 3, 11 pi over 6? So let's see if we can get there. So we're going to take this guy, and we're going to add and subtract 2 pi. Again, just convert your denominator. And 12 pi over 6 and negative 12 pi over 6 are your endpoints for this. It can't go past those. So if I add this to this guy, don't I get 11 pi over 6? That was perfect. That's exactly what I wanted. Now, if I add the negative, isn't that going to push me over? This is as high as I can go and as low as I can go. So this guy's out. So I can use this one, and I can use this one. I just want to stay within this negative 2 pi to positive 2 pi. And do I really have to add that? No, but I'm doing it so that you see it. Okay, so now, if I went through the pole, that exists over here somewhere. So I'm going to start with my radius, negative. I'm going to take my angle, and I'm going to add and subtract pi. And again, just convert your denominator. That's a 6. So we're going to keep it negative. So if we add 6, we're going to get 5 pi over 6. If we subtract 6, we're going to get negative 7 pi over 6. Now let's see if that point exists through your pole. So if I came through my pole, straight through, here I am. Am I at the 5 pi over 6? And if I would be at the negative 7 pi over 6, do you see that it adds up to the 12 pi over 6 still? So that's a good way to check. But I only plot one point, my positive. I only plot that one point. It has 4 names, 1 point. A little different. Just a little different. And so we're kind of working with your angles, but we're not really working with the trig part of it. So, all right. So let's try the last one. Let's do a negative. Are we okay with this? Now, I technically can't plot this point, because I can't plot a negative radius, right? So I'm going to take this right now and add and subtract 2 pi. I know this says negative, but I'm going to add and subtract 2 pi to it. Because my rule is, I take it and I add and subtract 2 pi. Then I negate it, and I add and subtract pi. So again, just hang with me for a minute. Convert your denominator. So I can name this point as 9 pi over 4. And if I subtract it, make it 7 pi over 4. So is either one of these out of my 2 pi? This guy, right? So I have this name, and I have this name. I still can't plot it though. I can't plot a negative radius. Now I take my rule and negate my radius. So if I negate a negative, what do I get? A positive. So now I take my angle and I add and subtract pi. Hang in there. We're almost there. I can convert my denominator. Make life easier. I take this and I add 4 pi. And I take this and I subtract 4 pi. Okay, so I should get this one and this one. How many plots am I going to get on my graph with these 4? 1. What should I plot? One of these, because won't they be the same point? So I'll take the easier. I'll do the 5 pi over 4. Because here's 5 pi over 4. I'm going to come out to a radius of 4. 1, 2, 3, 4. There's my dot. Okay. Now, through the pole, it exists at the pi over 4, right? But I can't plot a negative. My rule stays the same. Keep that, add and subtract 2 pi from the original. Negate it, and in this case I made it positive, add and subtract pi. Okay. You guys try number 4. Try number 4. over 4 and see how many angles you come up with. See how many names we can get for that. You can't always get 4 names. Sometimes you're just out of that negative 2 pi to positive 2 pi. 4. 4, 5 pi over 4. So it's almost like that one that we just plotted. Same plot. You're going to have the same plot for this guy. So let's see how many names you can come up with. You're technically plotting one point and giving it a bunch of names. So, Bo, you have one more name for me? Okay, I'll take that one. Chris, you have one more for me?
4 negative 2 pi over 6.
Okay, any other names? Nope, they got knocked out, right? So this guy, because it's all out of your 2 pi range. When you convert these, so when you're converting this to 4, remember that if I made this in 2 pi, that's 8 pi over 4. I can't be at 8 pi over 4 either way. So that's going to knock a few things out. All right, so for the homework, I think I just gave you a series of points. I want the plot points and all the names for it.